We have been told that the internet is the ultimate achievement of the information age. We've built a global nervous system of fiber optic cables and satellite links that allows us to move data at the speed of light. But the internet as we know it has a fatal flaw. It was built for connectivity, not for security. Every bit of data that travels across a classical network can be intercepted, copied, and stored without the sender or the receiver ever knowing. In a world of increasing cyber warfare and industrial espionage, our current network architecture is a leaky bucket. To solve this, we aren't just looking for better encryption. We are looking to rebuild the very way information travels. We are entering the era of the quantum internet. To understand why the quantum internet is fundamentally different, you have to look at the no-cloning theorem. In the classical world, information is cheap because it is infinitely reproducible. If I send you an email, a copy stays on my server, a copy sits on yours, and a copy can be made by anyone who intercepts the signal. But in the quantum world, you cannot copy a quantum state without destroying it. If you try to measure or read a qubit while it is in transit, the wave function collapses. The original information is altered, and both the sender and the receiver are instantly alerted to the presence of an eavesdropper. This is the foundation of a physics-secure network. The first practical application of this is quantum key distribution, or QKD. Instead of sending a secret message protected by a math problem, you send a key made of entangled photons. Because of the laws of physics, it is impossible for a third party to intercept that key without leaving a fingerprint on the data. If the fingerprint is detected, the key is discarded and a new one is generated. This creates a communication link where the security is guaranteed not by the complexity of the code, but by the fundamental structure of the universe. It is a zero-trust architecture at the subatomic level. But the real goal isn't just secure messaging, it is the teleportation of quantum states. Now, we aren't talking about Star Trek-style teleportation of physical objects. We are talking about using quantum entanglement to move information between quantum computers without the information ever actually traveling through the space in between. By entangling a qubit in London with a qubit in New York, we can swap the state of the first qubit to the second one instantaneously. The information disappears from one location and appears in the other. This allows us to link quantum computers together into a global quantum cloud, creating a distributed processing network that is exponentially more powerful than any single machine. The biggest engineering hurdle we face right now is the quantum repeater. In a standard fiber optic cable, the light signal fades over long distances, so we use amplifiers to boost it. But you can't amplify a quantum signal because that would require copying the qubits, which, as we know, is impossible. To build a global quantum internet, we have to develop quantum repeaters that can catch a qubit, store it in a quantum memory without collapsing its state, and then teleport it to the next node in the chain. This is the holy grail of quantum communications engineering. This transition will fundamentally redefine the concept of sovereignty and privacy. The nations that build the first functional quantum backbones will be able to operate with a level of informational integrity that is untouchable by classical cyber threats. They will have a dark web that is truly dark, invisible to any form of traditional surveillance. We are moving toward a bifurcated world, a classical internet for public consumption, and a quantum internet for high-stakes strategic, financial, and scientific operations. The age of the interceptable bit is coming to an end. We are building a world where the act of looking is an act of changing, and where distance is no longer a barrier to the transfer of information. The quantum internet isn't just an upgrade, it is a total reimagining of how the human race stays connected. It is a network that is as resilient, as complex, and as secure as the laws of physics themselves. If you want to see how we are laying the first nodes of this new global nervous system, stay with us. The signal is being sent.